The year was 1976. It was a time of cultural revolution, where music, fashion, and technology were all undergoing significant transformations. The 1970s were marked by vibrant colors, bold patterns, and an undeniable sense of freedom and experimentation. People were dancing to the beats of disco, and the world was on the brink of a technological breakthrough that would change the course of history. Disco was in full swing, with its infectious rhythms and dazzling lights captivating audiences everywhere. Nightclubs were packed with people grooving to the latest hits, and the disco ball became an iconic symbol of the era. But amidst the glitter and glamour, something even more revolutionary was taking place in the world of technology. And a new technological marvel was born, the Intel 8085 microprocessor. This tiny chip, no larger than a postage stamp, was poised to revolutionize the computing industry. It was a marvel of engineering, packing incredible power into a minuscule form factor. This little chip, with its complex circuitry etched onto a tiny piece of silicon, revolutionized the world of computing. It was a feat of miniaturization and efficiency, allowing for unprecedented processing power in a compact design. Engineers marveled at its capabilities, and it quickly became the cornerstone of modern computing. It brought the power of a computer from the realm of massive room-filling machines to everyday devices. Before the advent of the 8085, computers were enormous, often occupying entire rooms and requiring extensive cooling systems. They were the domain of large corporations and research institutions, far removed from the average person. Before the 8085, computers were behemoths, often requiring dedicated rooms and specialized operators. These machines were complex and expensive, accessible only to those with significant resources. The idea of a personal computer was a distant dream, something that seemed almost impossible given the technology of the time. The 8085 changed all that. It was a game changer, a catalyst for the personal computing revolution. With its introduction, the dream of having a computer on every desk and in every home started to become a reality. The 8085 made computing accessible, affordable, and practical for the masses. Its compact size and affordability paved the way for smaller, more accessible computers, heralding the dawn of personal computing. Suddenly, computers were no longer the exclusive tools of scientists and engineers. They became essential tools for education, business, and entertainment, transforming the way people lived and worked. It was a game changer, much like how smartphones revolutionized communication in the 21st century. Just as smartphones have become indispensable in our daily lives, the 8085 microprocessor was the foundation upon which the modern computing world was built. Its impact is still felt today as we continue to build on the innovations it introduced. The 8085 microprocessor, despite its age, remains a cornerstone of computer science education. Its design is studied by students and enthusiasts alike, providing valuable insights into the principles of computer architecture. It serves as a bridge between the past and the present, illustrating the evolution of technology over the decades. Its simplicity and elegance make it an ideal learning tool for understanding the fundamentals of computer architecture. By studying the 8085, students gain a deeper appreciation for the complexities of modern processors and the ingenuity of early computer engineers. Even today, its influence can be seen in modern microprocessors, which, though significantly more powerful, still share the same fundamental principles. The legacy of the 8085 lives on, a testament to the enduring impact of this groundbreaking technology. It reminds us of how far we've come and inspires us to continue pushing the boundaries of what's possible in the world of computing. The 8085 found its way into a surprising array of devices, from simple household appliances to sophisticated industrial systems. Remember those early microwave ovens with the push-button controls? They were a marvel of their time, allowing users to set precise cooking times and power levels with just a few presses. Many of them used the 8085 to manage cooking times and power levels. Traffic lights, those ubiquitous symbols of urban life, also benefited from the 8085's processing power. Before the advent of microprocessors, traffic lights operated on simple timers, unable to adapt to the changing flow of vehicles. The microprocessor enabled more sophisticated traffic flow control, adapting to real-time conditions and reducing congestion. This meant that traffic lights could now respond to the actual number of cars on the road, making city driving a bit less chaotic and more efficient. Industrial automation, too, saw significant advancements thanks to the 8085. Factories that once relied on manual labor for repetitive tasks began to integrate automated systems. Robots on assembly lines, controlled by the 8085, could perform repetitive tasks with precision and speed, boosting productivity. These robots could work tirelessly, ensuring that products were assembled with consistent quality and at a faster rate than human workers. The impact of the 8085 wasn't limited to just controlling machines. It also found its way into various tech gadgets of the era, making them smarter and more efficient. It also played a crucial role in the development of early personal computers. These early machines were the precursors to the powerful computers we use today, and the 8085 was at the heart of many of them. The Altair 8800, considered by many to be the first truly successful personal computer, was powered by the 8080, a close cousin of the 8085. This machine sparked the personal computer revolution, inspiring countless hobbyists and future tech entrepreneurs. The legacy of the 8085 and its relatives is evident in the technology we use every day, from the simplest gadgets to the most complex systems. Imagine a bustling city with a network of roads and highways. Cars, buses, and trucks move in a coordinated dance, each vehicle knowing exactly where to go. This intricate system keeps the city alive and functioning smoothly. That's essentially what the data and address buses are to a microprocessor. They form the backbone of the system, ensuring that information flows seamlessly between different parts. They act as the information superhighways, carrying crucial data between the different components of the system. Just like highways in a city, these buses ensure that data reaches its destination quickly and efficiently. The data bus, a bidirectional 8-lane highway, allows for the flow of data in and out of the microprocessor. This means that data can travel to and from the processor, enabling it to perform its tasks. Each lane represents a single bit, the basic unit of information. These bits are the building blocks of all data, whether it's a simple number or a complex image. 8 bits together form a byte, which can represent a letter, number, or symbol. This is how information is structured and understood by the microprocessor. The address bus, on the other hand, is a one-way 16-lane highway. Unlike the data bus, it only carries information in one direction. It's responsible for carrying the addresses of specific memory locations that the microprocessor needs to access. These addresses tell the microprocessor where to find the data it needs. Think of it as the postal service, delivering mail to the right houses by following the addresses on the envelopes. Just as a mailman ensures that letters reach the correct homes, the address bus ensures that data reaches the correct memory locations. Together, the data and address buses create a harmonious system, much like a well-organized city. They work in tandem to ensure that the microprocessor can access and process information efficiently, keeping the entire system running smoothly. Section 4. General Purpose Registers, the microprocessor's quick memory. Inside the 8085 microprocessor, we have the general purpose registers, acting like small, readily accessible memory slots for quick data storage. These registers, labeled B, C, D, E, H, and L, are like the microprocessor's scratch pad, holding the data it needs for immediate use and quick access. Each register can store an 8-bit value, which is essential for basic operations. However, they can be paired up, B with C, D with E, and H with L, to handle larger 16-bit values, enhancing their functionality. This pairing allows the microprocessor to work with more complex data and perform more sophisticated calculations efficiently. An analogy for the registers would be a chef's workstation in a busy kitchen, where everything is within reach. the chef keeps frequently used ingredients within arm's reach for quick and efficient access, ensuring smooth workflow. Similarly, the microprocessor stores frequently used data in these registers for faster processing, optimizing its performance. Section 5. The brainy ALU, calculations and decisions made easy. At the heart of the 8085 lies the Arithmetic and Logic Unit, or ALU. This is where the real thinking happens. The ALU is responsible for performing all the arithmetic operations, such as addition, subtraction, multiplication, and division. But its capabilities extend beyond just crunching numbers. The ALU also handles logical operations, such as comparing two values to determine if they are equal, greater than, or less than each other. These logical operations are crucial for decision-making within programs. Think of the ALU as the brain of the microprocessor. Just like our brains process information and make decisions based on calculations and logical reasoning, the ALU processes data and makes decisions based on the instructions it receives.